So now we're familiar with rational numbers both in fraction and decimal form, and we're now going to do an assignment that kind of puts these in context, and that's the actual I can statement here. So 4.5, I can use rational numbers to solve problems in context. So we're going to use these in the context of some story problems in various settings, and what I'd like to do is just show you a little bit of what your assignment's going to be like. This is kind of a copy of what you're going to see on your assignment. I'm not going to do all of the problems or do every part of this, but it should be enough that you'll be able to get started and do this on your own. So this problem is about, at least for the first part of it, it's about Numberline City, and there's one straight road in this city, and all the residents of Numberline City live either to the east, which is in the positive direction, so that's going to be to the right, or to the west, that's going to be in the negative direction of Town Hall. And Town Hall is right in the middle. Okay, so I am going to go ahead and put that one right here. So Town Hall is right here. So I'm going to put a T for Town Hall, and it's right at 0. Okay, so it says the town ends at negative 10 units to the west and positive 10 units to the east of Town Hall. So negative 10 is the western limit of the city limits, and positive 10 is the eastern limit of the city limits. And it says all addresses are given as positive or negative rational numbers, so they might be fraction or decimal form. And it says mark each address, and it says mark it with a dot, mark it with the first letter and the number address on the map of Numberline City below. So you'll notice that I put a dot for the 0, I put a T there for Town Hall, and then I put a 0 there because that's the coordinate. And those coordinates are going to be helpful so you don't have to look back here and refer to which is which. And you'll notice that what I've done here is I've started every one of these off. Each one of these you can just represent them with the first initial because there are no repeats as far as initials or anything like that are concerned. So let's go ahead and look at a couple of these. So here's, again, I'm not going to graph every single one of these. I am going to graph this one here. I'm going to graph Allison and Betsy. So let's find Allison and Betsy. So Allison lives at negative 2.5. That's her address. So negative 2.5 would be in between. It would be between negative 2 and negative 3. So it's going to be about right here. So I'm going to put a dot right there. I'm going to say that's Allison, and then I'm going to label that as negative 2.5. That is her address, and you do need the negative there. Betsy lives at 1 3/4. So notice that we've got a mix of decimals and fractions here. So Betsy lives at 1 3/4. So 1 3/4 is going to be between 1 and 2, a little bit closer to 2. So I'm going to put a dot right there. I'm going to put a B for Betsy, and I'm going to put 1 3/4. Whoops, 1 3/4. And I want to point something out here. So 3/4 there, so we've got that one labeled correctly. You'll notice that this one is written as a mixed number. We don't often do that, but that kind of makes sense in a setting like this. So she's 1 3/4 of a block to the east. Chris is 5 1/2 of a block to the east. And then if you take a look at this one right here, Frank is 10/4. So there are a couple things about that. First of all, it's not reduced. We can actually simplify that. We can simplify that to 5/2. And it's also not a mixed number. You may want to make that a mixed number because remember, on story problems you can choose the best way to represent your answer. So what it says here is answer the following and show your work and your thinking. So it says how far is it from Allison's to Betsy's house? So we want to know how far it is if Allison walked to Betsy's house or Betsy walked to Allison's house. So there are a couple different ways to do this. I want to point this out. It's saying how far. That's asking for a distance, and we want to make sure that distance is positive. So I'm going to give you a little hint here that may come in handy down the road in other classes, especially when you get into higher math. If you want the answer when we find the difference between these two addresses to be positive, if you will do the right address minus the left address, you will get a positive answer. It'll work that way every single time. So what we're going to do on this one, to find how far it is from Allison's house to Betsy's house, we just want to know what's the positive distance. How far would it be? So we're going to take the right one. So that's going to be 1 3/4, and we're going to subtract the left one, which would be negative 2.5. And you'll notice what happens here. We end up with 1 3/4. We've got two negatives next to each other, so we're going to be adding 2.5. So we've got 1 3/4 and add 2.5. So we could do a couple of things here. And again, because this is a story problem, you can choose the best way to write the answer. I probably would go ahead and type this into the calculator like this, or maybe do 1.75. Remember, it's helpful to recognize those common rational numbers, plus 2.5. If you need a calculator to help you get that answer, that's totally okay. I'm going to double check on a calculator, and I am going to show you a calculator that I'll use on the screen sometimes. It looks like this. So I'm just going to go ahead and type this in, and you'll be able to see. The advantage here is that I can just pull this up on the screen. I don't have to split screens or anything like that. So I'm going to do 1.75, and then I'm going to add 2.5. And we end up with 4.25. So the answer right here is 4.25. Now, it doesn't say blocks or anything, I don't think. Yep, it doesn't say there are blocks or anything. So we just say units on this particular one. So there's our answer on that one, so 4.25. And again, if you wanted to answer that as 4 1/4 units, that would be totally okay. Either way would be fine. But we're after 4 1/4, 4.25. Okay, then it says who lives closer to the store, Allison or George? So we've got a couple other people we need to graph on here. I'm going to make this just a little bit smaller so we can fit them on here. So we need George. George is at negative 6.25, sorry, 6.2. So that would be in between negative 6 and negative 7, a little bit closer to 6 than 7. We're going to put a G for George, and his address is negative 6.2. And then we also reference the store. So we've already got Allison on here. We've got George on there, and we need to know where the store is. So let's find the store. The store is at negative 4.8. So negative 4.8. So we're definitely to the west of Town Hall, in between 4 and 5, a little bit closer to 5. So this is going to be the store, and the address is negative 4.8. So what we want to do is, now you may be able to eyeball this. It definitely looks like the George is closer to the store, but let's double check and make sure that the numbers kind of bear that out. So if we want to find how far Allison is from the store, let's stick with this whole idea of doing right minus left, and it will figure out a positive answer for us. So what we're going to do is we're going to do negative 2.5 because Allison's on the right, and then we're going to subtract, or we're going to minus the store's address of negative 4.8. Okay, we'll go ahead and figure out what that is. Let's see, so we've got negative 2.5, and then minus a negative number would be adding, so I'm going to do that, and then 4.8, and we end up with 2.3. Now, just for the heck of it, I'm going to do negative 2.5 minus negative 4.8. Again, notice the difference between a minus and a negative, and your calculator should look the exact same. It's going to give us the same answer, so 2.3. Okay, so I'm going to put a dotted circle around that. That's the distance from the store to Allison, or Allison to the store. Let's do the one for George. So George is at negative 6.2 and the store is at negative 4.8. So I'm going to do the right one, which is the store. So that's negative 4.8 minus negative 6.2. And I'm going to go ahead and change that, negative 4.8 plus 6.2. And I'll go ahead and do the math for that. Again, if you can figure this out in your head, that's great. If you need a calculator to do some of these, that's just fine. I'd encourage you to have a guess as to what the answer is going to be. Like, we know the bigger one's going to be positive here, so the answer is going to be positive. So we get 1.4. So 1.4. So I'm going to circle that. And the answer to the question here, it says, who's closer? So we're going to write George is closer, period. He is only 1.4 units away, while, let's see, what was her name? Allison. Allison is 2.3 away. So there's our explanation. There's our reason. So George is closer. That's the big deal here, is that we answered the question. George is closer, and we've got work to support that. Okay, so you have several other problems that are like that. So I would encourage you to graph everything, label it like I have here, and then do the subtraction problems as I've indicated. So remember, if you do the right number minus the left number, you're always going to get a positive number, just like we did here. Notice we were working with a bunch of negatives, but our answers worked out to be positive. Okay, let's take a look at two other problems. These involve rational numbers of various types, and we've kind of got to think about what's going on here. So it says, of the 12,000 applicants to Carver College, only 1/3 of them were accepted. So only 1/3 of them were accepted. So all 12,000 didn't get in, only 1/3 of those got in. You may be able to do that math in your head, but we're definitely going to show you our work and thinking anyway. And then it says, however, only 37.5% of those accepted decided to attend the college. How many of the original applicants, so those original 12,000, decided to attend the college? So this is actually a two-step problem. The first thing we need to do is there were 12,000 students who applied to begin with, and only 1/3 of them were accepted. So remember, when you use the word of means multiply. So we're going to do 1/3 of the 12,000 here. So that's a multiplication problem. So I'm going to go ahead and bring up the calculator. I'm going to clear everything off, and we're going to do 12,000, and then I'm going to do times, and on this calculator I don't have the sophisticated fractions and stuff like that. What I'm going to do is I'm just going to put 1/3 in parentheses. So I'm going to do 1 divided by 3, and I'm going to hit enter, and it tells me the answer is 4,000. Okay, so this is 4,000, but that's not the answer to the problem. That's how many got accepted. So this many applied, 12,000 applied, but the college only accepted 4,000 of them. So we have that. So this many applied, and then they send out 4,000 acceptance letters. And then they have to decide whether they're actually going to take that. Maybe they applied to different colleges and they've got a choice to make. So 37.5% of these, the ones that got accepted, actually chose to attend there. So we want to do another problem. We want to do 4,000. We want 37.5% of those. Remember, of means multiply. So we're going to times that by 37.5%. Now, most of you are aware of this. If you're not, we never use percents in a problem. When we throw those into our calculator, we're going to change those to a decimal. So we're not going to use that. We're going to do this problem on our calculator. Remember, we're going to remember the decimal equivalence. So we're going to move the decimal over 2 places. 37.5% is going to be 0.375. So we're going to multiply it by 0.375. So again, we're going to grab the calculator. We're going to throw that into the calculator. We're going to do the 4,000, and then I'm going to times that by 0.375, and we get 1,500. So the answer here is 1,500. So we've got a couple different answers that we got. We got 4,000 and we got 1,500. Remember, the question is, how many of the original applicants actually decided to attend Carver College? 12,000 applied. They didn't accept all of them. They only accepted 4,000 of them. And then of the ones they accepted, only 37.5% of them decided to attend that college. So the answer is right here. So how many of the original applicants? 1,500 actually chose to attend Carver College. Okay, so two-step problem there. We've mixed some fractions with some decimals and some percents. Really good thing to be able to do there. Let's take a look at this last one here. It says, during his summer job, Ross earned $7.25 an hour. So we've got a decimal right there. If he worked 5 days per week and worked 6.5 hours per day, how much did he make each week? Well, let's think about this. He's going to work 5 days, and he's going to work 6.5 hours per day. So he makes this much per hour. We need to figure out how many hours he actually worked in a week. So let's take those 6.5 hours, 6 1/2, and he does 5 days of that. So we would times that by 5. So I'm going to grab the calculator, and I'm going to show you on yours. You can use the fraction input key and stuff like that. I could do a couple of things here. So one thing I could do is I could just say, oh, I'm going to type that in as 6.5 times 5 and do it that way. That would work just fine because we're familiar with those common rational numbers. So I can do 6.5 times 5. He's going to work 32.5 hours a week. Another thing that we could do is I could be kind of clever on a calculator like this. I could do 6 plus 1 divided by 2. That's 6.5, 6 plus a half. Okay, and then I could times that by the 5. And we get 32.5. So either way, and this is a story problem, so we can write the answer however we want. I'm going to go ahead and say that that's 32.5 hours in 1 week. and then he earned $7.25, and we want to know how much did he make. So we take that 32.5 hours, and he earned $7.25 per hour. Now, I'm going to do this on this one. I'm not going to make a big deal of this now, but this is going to become a big deal later on. I'm going to go ahead and cancel this hour with that hour. So the units are going to cancel. So you'll notice that the only unit left is dollars. So the answer to this is dollars. So let's check and see, what do we get when we do 725 times 32.5? So $7.25 an hour. We're going to times that by 32.5. And he's going to end up making, let's see, that's $235.62 and just a little bit more. So let me write this down. $235.62 and just a little bit more. Now, when you're answering a question like this, it's best to round to the nearest penny. We're talking dollars and cents here. So we're going to say that what he's actually going to earn, his paycheck, and this is something that's just standard. When we're dealing with finances, we do proper rounding. So if this is a 5, we'd round up. If this is a 4 or less, we'd round down. So that's enough that he's actually going to make 63 cents. And we'd circle that, and that's the answer. So we did this in stages. We figured out how many hours he worked, and then we multiplied how many hours he worked by how much he makes per hour, and we got this answer right here. If you wanted to do this all together, we could do this. We could do, he works 6.5 hours a day, 5 days in the week, and then he makes $7.25 an hour. We could multiply those all together at the same time, and you'll see that we get the same answer. So either way you want to do it is fine. So if you want to use one of those calculators that I've got, if that's what you've got available to you, or you've got one of those fancy TI-30 XIIS or B or whatever you've got, as long as you're getting these answers and you're plugging those into your calculator correctly, then you should be in good shape. Okay, good luck on the assignment.